Okay, we are now going to go through the disassembly procedure for the Positraction differential gear set. Every front axle, rear axle has two sets of gears in it if it's a driven axle. Obviously we've got the ring gear and the pinion gear that we've looked at already, but inside of this differential case is a differential gear set that has two side gears and two differential pinion, or I'm sorry, in this case it has four differential pinion gears, and sometimes those are referred to as spider gears, but the correct term is differential pinion gears. The more pinion gears there are, the stronger this is, and since this is a Positraction differential, it's chances are it's going to take some high torque and abuse, and so they add two more differential pinions, and I'll show you those when we get in here. But we are going to remove the ring gear first, and to do that I've got a vise here with copper jaws that I've installed. The copper jaws you can add to just about any vise. You can get them in different lengths. I highly recommend that you use these rather than the cast iron jaws that the vise comes with. These are soft, it'll conform to whatever you're clamping into it if necessary, and they won't damage what you are clamping into the vise in most cases. There are also aluminum jaws that are magnetic. You can just stick them to your existing jaws. There are rubber jaws, there are plastic jaws, there are fiber jaws. There's all kinds of jaws you can use in vices for holding different components to prevent damaging them. Well, what we want to do here is turn this differential case over and remove these bolts that hold the ring gear in place. These bolts, if you look on the top of them, have the letter L, which means they are left-handed threads, which means right to tight does not work here yet. It's right to loose. So we're going to turn these clockwise to loosen them, but they're supposed to be torqued to a specific torque, and it's usually difficult to loosen them just here on the bench. And so I like to put it in a vise to hold it in place. And I will lift it up just a little bit so that as we loosen the bolts and need to tap that ring gear down, we've got space for the ring gear to drop. When you clamp it down, you want to make sure that you're not clamping on any of the pinion pins or anything that could be damaged inside of the or outside or inside of the differential case there. So looks like those are 9/16. And if you remember, once again, we're going to turn it clockwise to loosen them. It does not feel like it is left to loose. What's going on here? Well, upon further investigation, even though these bolts appear to have the letter L stamped on them, they are obviously right-handed threads, not left-handed threads. Left to loose is removing the bolts. There are some left-handed threads in this differential case that hold the case together, but in this particular instance for this ring gear, they are left-handed threads. So I'm going to get all of these bolts, I'm sorry, they're right-handed threads. I'm going to get all these bolts removed, and then we'll tap the ring gear off. Okay, so here comes the ring gear down, and we can lift the differential case out, set it off to the side. Here's the spacer for these 456 gears. Also, I want you to see that the each bolt for the ring gear also has a lock washer, a split lock washer that helps ensure the bolt does not come loose while driving down the road. Now we are going to, on these new bolts, besides the lock washer, we're going to put some thread lock on there also. So let's get this ring gear off to the side and start the disassembly of this differential case. All right, now that I've got the ring gear removed and the bolts and the lock washers removed, some of those lock washers were stuck in there. We need to get these side bearings off. There's a side bearing on each side of the differential case here, and we need to remove those. The service information, the repair manual calls for a puller. So to put a puller on here, a 2-jaw puller, there's a notch right here in the side. There's 2 notches. So if you look right there is a notch in the case for 1 jaw, and then here on the other side is a notch for another jaw. And we can come in with a 2-jaw puller and pull up on that, but to pull up we've got to be able to push down with the threaded shaft. So we've got an insert that fits in the hole where the axle shaft would normally go, and that's going to give us a base to use the puller, a 2-jaw puller that I've got right here. And we'll just come in, get that puller in those 2 notches, make sure we're under the inner bearing race, and then use this puller to pull the bearing off. So let's see, it's 5/8 on the puller. We're going to use a adjustable wrench here to hold the puller housing steady as I turn the threaded shaft, and we'll see how easily, oh wow, it's coming right off, that bearing comes off, not fighting us at all, which is pretty unusual. Almost every bearing that I've ever had to deal with on differentials has fought me trying to remove it. All kinds of popping and kicking, really stressing the puller. But this one is just, it's coming off easily, so that makes it nice. So it either comes off easy because the bearing has spun possibly inside and wore down this surface where the bearing is pressed on, or it's just not that tight of a fit out of the factory. Now looking at it, I don't see evidence of any damage from a spinning bearing, which is pretty unlikely anyway. So that we've got that bearing removed. This old bearing made by Hyatt, so that's a pretty old bearing. I don't think they're in existence any longer. We are replacing it with coil bearings. And, so we'll set that off to the side. We need to turn it over and get the other off also. We'll try this same puller. It also has the two notches underneath there to remove the bearing, but this two-jaw puller that I have is not the exact one called for to remove this particular side bearing. It worked okay on the other bearing. This one comes in underneath the outer bearing cage and does not grab the inner race, which means as we try to pull this off, the cage will probably just bend and the rollers will fall all over the place. If that's the case, then we'll have to use a bearing splitter and a press to remove it. All right, so let's try pulling this bearing off, and we'll see see if we just split the cage and roll bearings all over the place, or if it's loose fitting like that other side, then we might be lucky and be able to just pull the whole thing off without having to use a bearing splitter. So, give it a shot here. Looks like we're lucky. It's pulling it up anyway. It is distorting the cage a little bit, but we are replacing this bearing, so it doesn't matter. We just want to get this off of here so that we can do some tests on the case run out next, as soon as we get this bearing off. That's as far as our puller will remove. Didn't quite get it off all the way, so let's see if we can come in a little bit deeper now that we've got it up a little bit more. Yes, we can. There we go. All right, we've got both bearings, both side bearings removed. And the next thing we need to do is check the case for runout. And the runout that I'm referring to here is right here on this machine surface where the ring gear sits. We don't want that to be wobbling up and down as it rotates. And then there's this surface right here that centers the ring gear. We don't want it to be moving back and forth as the differential case rotates. So there's a maximum specification in the service manual of 3/1000ths of an inch for case runout. And so we're going to get set up now with some V-blocks to measure the case runout. We're going to measure the differential case lateral runout, which is the side-to-side runout of this machine surface here where the ring gear rides, and it should not be more than 3/1000ths of an inch. If it is more than 3/1000ths of an inch, then that can cause the ring gear to wobble back and forth because the ring gear, of course, is bolted to it. Even if you had a perfect ring gear, if you put it up to a differential case that has runout, the ring gear is going to have runout also, which can affect the backlash variation, which means the backlash can vary from one tooth to the next, typically in a pattern, higher on one side, lower backlash on the other as this differential case wobbles back and forth. It can also cause a contact pattern variation, which can affect the noise that a differential ring and pinion gear set can make. So I've got the dial indicator set on 0. Let's rotate this around. I've got it lined up with the A on Armasteel on the marking here on the back. So let's just rotate carefully. back to the A. It looks like it went down as far as that 45, which is 5 thousandths of an inch run out. Let's try it again. Goes up to 1.5, 2. And then down to the 45. And then back to the 0 right there on Armasteel. So that's 7 thousandths of an inch run out, more than double of what the maximum allowed run out is on this differential case. Now that can and probably will show up when we do a backlash variation check, which means that this thing is wobbling back and forth, and it could result in some noise. And so why would this thing be wobbling back and forth? Who knows what its history is as far as changing gears, changing the ring gear, possibly pounding on it or dropping it or something over the years. It's a 1963 model year differential case, and so of course it's 51 years old, 52 if you realize it was built in December of 1962, but it's definitely got a little bit of a problem there with the excessive lateral runout. Now the next check we're going to do, which is a big one, is the radial runout. So this surface right down there, we're going to put this dial indicator on that surface and see how much up and down runout it has as it rotates. So let me get the dial indicator set up for that. Okay, I've got the dial indicator set up, as you can see, on this machine surface right here, and I've got the roller tip on there. If you don't have a roller tip, but just a tip that's wide that'll glide over that surface will work also. I'm going to zero the dial indicator right there. Actually, let me zero it at the A on the Armasteel brand here on the side. And so now we're going to rotate it around. Once again, the maximum specification is 3 thousandths of an inch. On modern differential cases, every one of these I've measured has been 0. But this one's 51 years old, and machining may not have been quite as precise back then, but let's take a look. So I see 1.5, 2, and we're back to A on the Armasteel. So only 2 thousandths of an inch run out. That's within specification. So at least we don't have radial run out causing the ring gear to move up and down. That's really good. But we have excessive lateral run out, this side to side run out. Okay, so next we're going to take the differential case out of the B blocks and take these bolts out of the differential case. As you can see, it's split in the middle, and we're going to split this thing apart and get the differential gears and the clutch plates out of there. Okay, we're going to take this positive traction differential case now and clamp it in the vise just to hold it still while we take these bolts out that separate the two case halves. These bolts do have also a giant L on them, letter L for left-handed thread, and sure it'll focus on that. Looks like I'll back out just a little bit here. Anyway, there is a L on these bolts, and it does say right in the service manual that these bolts have left-handed thread. So unlike the ring gear bolts that also had an L on them, I'm going to once again turn these clockwise in an attempt to loosen them. The reason I stopped turning clockwise on the ring gear bolt is it felt like it was getting tighter to me as I tightened it, or as I turned it clockwise. But as I turn this one clockwise, it gets loose. So it's definitely, they're definitely left-handed threads that separate or that hold these two case halves together. So I will get these bolts removed and then we'll separate the case half. Okay, as you can see, I've got the differential case bolts loosened up, and we'll take those out right now. I'm going to set those off to the side. We're going to lift the upper half of the differential case off. Here's the upper half here. And you'll notice in this upper half there are some notches in there. Those notches are what these Positraction clutch plates slide into, the outer clutch plates. They lock into the housing. And then the inner clutch plates, so let me take this outer one off. So here's the outer clutch plate. Here's the inner clutch plate right here next, and you'll notice it has teeth that spline to the same gear that your axle shaft would spline to, that connects to the side gear. So we have inner and outer clutch plates. Let me get this inner one off. Use a little pick here. Come on, it's just hydraulically stuck. There we go. So we have outer clutch plates that have these tabs on the outside, and then we have inner clutch plates that spline to the side gear. So you'll notice we had a flat one. This one in the middle, I believe, is supposed to be the dished plate. In other words, it won't be flat. If I recall from the instructions, it should be dished kind of like a spring. And then another inner plate. These plates are smooth, unlike the later model Positractions that had the little crosshatch marks in them. These plates are smooth, and the replacement plates that the owner of this vehicle has provided from Spicer are also smooth. So there's all the clutch plates from the one side, and then here is the gear that your axle shaft would slide into. It also slides into the side gear. Here's our side gear that fits into this cup. And notice that they can spin independently of each other at the moment, but once you put the axle shaft all the way through, these two pieces are locked together and have to spin the same speed as the axle shaft, or same speed as your tire. And so we'll set that off to the side. Then we have our 4 differential pinion gears. Set this case off to the side here. As we lift those out, we're supposed to inspect for any signs of damage. I'm not seeing anything. Surface looks good. up and down play. I don't feel any up and down play. So that's good. Look at this other side. Same thing. It looks pretty good. So whoops, I'll set that off to the side here also. And then in the other side of the differential case, we have the other side gear, the other cup, and then the other set of clutch plates. We've got the Positraction differential case disassembled. Inside of each case half, we have a set of clutch plates, a side gear, and a side gear retaining ring that I was calling a cup earlier. I looked up the official name, and it's a side gear retaining ring. And they have the same part number, so I guess it doesn't matter which side they go on. These side gears have the same part number also. And the side gears just sit inside of those retaining rings. On the back of the retaining ring, as you can see, we have some gear teeth, and those gear teeth are what spline to the Positraction inner clutch plates that, as I showed you on disassembly, have the clutch or have teeth on the inside edge of the plates, and then the outer clutch plates have these tabs on the outside that spline into the 4 notches in the differential case half. So what happens here is that as you're driving down the road and either or neither tire has lost traction, the side gears aren't rotating at all, the differential pinions aren't rotating, everything just spins as one big assembly. But then if you have one tire that breaks loose, anyone who's ever driven a vehicle with an open differential knows that the tire that breaks loose gets all the power, and the tire that has traction doesn't get any power. Well, a Positraction differential tries to prevent that. And what happens is, as one tire breaks loose, it causes the side gear on that side of the vehicle, because the side gear always spins the same speed as the tire. As that side gear starts to spin, it causes the rotation of these differential pinions also. And it turns out that the angle of the teeth ground here on the differential pinions versus the side gears is such that when the whole assembly is put together like this, and it starts to rotate when one tire has lost traction, both of these differential side gears and their retaining rings tend to want to spread apart. And if you think about it, as the differential pinion gears are turning against the side gears, there's a force that wants to push those gears apart. It's like the ring and pinion gear set. Under acceleration, those gears want to push themselves apart, but under deceleration, they want to pull themselves together. And that's because it was ground, the gear teeth were ground as a hypoid gear set. These are not hypoid gears. These are just beveled gears, and they want to push each other apart, whether you're accelerating or decelerating, going forward or backwards. And so any rotation at all of one tire going faster than the other is going to cause this whole side gear to lift up or push apart from the other side gear. Well, sitting right there waiting for that pushing apart action to occur is this set of clutch discs. so the clutch discs, the outer discs here that have the tabs that spline into the differential case half, they are always spinning and powered because of the ring gear. But the second set of clutch plates, the inner plates, they're not splined to the differential case. They're splined to that side gear that starts to spin. And that separation action of pushing the side gears apart under acceleration causes these clutch plates to squish together. And by squishing them together, it causes the outer plates to want to lock to the inner plates. And by doing that, since the outer plates are splined right to the differential case itself, it forces the inner plates to turn the same speed as the differential case, and that stops the tire that was going to slip from slipping, and it provides through the clutch plates on both sides. It locks both axle shafts to the differential case. It doesn't lock them, but it tries to lock them. There's a limited amount of slip, which why later on they were called limited slip differentials. Positraction is just another name for a limited slip differential. These do not actually lock, but it comes close to locking. And over the years, these plates wear out and get thinner and thinner, which means it won't lock as well as it should. And so a set of replacement plates can bring the lock or the near locking action, the limited slip action, back to normal where it should be. And one thing I noticed on disassembly of this axle is this positraction gear set it was assembled incorrectly. There are two thick plates that are 90 thousandths of an inch thick, and the outer plate, and then there's another one that's 60 thousandths of an inch thick. According to the service information, this thinnest plate should have been on the outside and go next to the case, and then alternating inner and outer plates with the two thick ones on the outside. And both the left and right sets of positraction plates were not assembled correctly because they have the thinnest clutch plate, the 60 thousandths of an inch one, in the middle rather than on the outside near the differential case. And so when we put the new plates in, we will assemble it properly. And while we're here talking about limited slip differentials, because of that slipping action, it takes a special lubricant. And I'm sure most of you know this, but there's regular axle lubricant. This is General Motors rear axle gear lubricant that you put in any differential that has an open differential. But then there's also limited slip differential lubricant additive that you add if it has a limited slip or positraction style with clutch plates differential. And so you need to add this if it has clutch plates on a positraction style differential case. That allows for some slipping to take place without the clutch plates chattering as you turn corners, because every time you turn a corner, these inner and outer plates are going to be rotating independently of each other, spinning inside of each other when you turn the corner, because in a corner the left and right wheels spin at different speeds. They have to. They're in different arcs. So that is the disassembly and inspection of the differential case. Next, we're going to clean this up, try to get some of this surface rust off of this machine surface here where the ring gear needs to sit, so we'll reduce the overall lateral runout, and then start the reassembly procedure. Okay, I have taken a knife sharpening stone and some WD-40, and I've cleaned up the surface rust best I can along this surface where the ring gear needs to bolt. And we're ready to start reassembling the Positraction differential case here. But we've got a little bit of a dilemma. The differential disc plate provided part number 22233X from Spicer for this differential came with 4 flat 90 thousandths thick outer clutch plates, like it should. And it came with 4 of the 90 thousandths inner plates, like it should. And then it came with 2 dished washers also. You can see that these, I'm going to lay it down, it does not, these are not flat, they're dished. Actually, I made a mistake there. Out of the 4 outer ones, 2 of these should have been 60 thousandths of an inch thick, and 2 of them should have been 90. Well, they're all 90. Which means we're going to be 30 thousandths of an inch too thick when we put this together. And the old set of clutch plates that we had here did have the 2 60 thousandths of an inch flat plates in it, but it did not have the dish plates that it should have had, unless it actually did have the dish plates, and just over time they flattened out, which is what I'm thinking possibly has happened. So what I'm going to attempt to do here, we'll see if it bolts together and does what it should, is I'm not going to use 2 of the new thick flat washers. We're going to substitute the 2 of the old 60 thousandths ones for the new ones. There's very little wear on these. I can still see the machining marks on them, so we're just going to reuse those. But we're going to add these dish plates. And the service manual tells us to lubricate each clutch disc and plate and install in the ring gear flange half of the case, stacking in the following manner. First, a 60 thousandths plate next to the case. So the 60 thousandths plate are these 2 that I'm keeping from the old clutch pack. And so they go in the case first. Like that. Then a splined clutch disc. Except I haven't lubricated any of these. So get some differential oil here. Put a little bit in there. A little bit in there. Make a little bit of a mess here. Clean up. But, soak these, or get these discs all coated with oil. So we'll put a splined clutch disc in on top of that flat washer next. And then a 60 thousandths Belleville type. It says assemble this plate with the inside diameter in contact with the disc nearest the case. So here's our Belleville plate, and it says to have, since this is dished like this, it says to have the inside diameter nearest the case. So we're going to put it down like that. Coat this other one. Have it down nearest the case. And then, of course, splined clutch discs, all covered with oil. And then the flat 90 thousandths plates that spline to the outer housing. Got all that in there. And then of course our side gear retaining ring. And we're going to have to line up these gear teeth with the inner clutch plates. And as we put that in, we're going to have to rotate it a little bit to get it to line up and drop down into those clutch plates. And are we in yet? Doesn't look like it. I have to rotate it just a little bit to get it to drop. Same thing on the other side. Let's get that ring gear in there. Or side gear, I mean. Get some lube on there. This side gear retaining ring down in, and see if we can get it lined up with those inner clutch plates. You've got to make sure they're lined up and down in. There went once. There's two of them. Oh, okay, there's the second drop. So we dropped through two inner clutch plates. And installed the side gear retaining ring and the side gear. Now, in looking at the amount of gap sticking up here, it appears that both of these are down in all the way as far as they should go. Look down in, it's hard to tell, but you've got to make sure that it's down in all the way. It's difficult to turn this though without the axle shaft. Guess we could just lift it up. Looks like we're on the one, but we're not down all the way on the other one yet. Oh. Down now. Ah. Nope. Still can't tell. So, I'm going to lift that back out just for a minute. And maybe it would be easier to put it together the other way. Oh, that's what the problem is right there. Since we've got this Belleville washer on there, and the old differential case or clutch plates that had flattened out or wasn't even there, it's giving us some resistance and a little bit of gap in dropping onto the teeth of this last clutch plate. So looking at we've got the beveled plate here. It just barely has some notches there for the teeth, excuse me, of that next clutch plate right there. Okay, so it does fit. And then our flat 60 thousandths plate. And if we can hold that all steady in one piece. We could get that all set up inside, oh, right where it was. So it was in place. It's just that Belleville plate is giving us some extra resistance there. That Belleville plate is going to preload those clutch discs so that the slightest rotation of these side gears versus the differential pinions will give us that push away force that will finish applying the clutch plate. So I believe we are there, installed properly on those. And we'll find out when we try to bolt the case halves together. If we can't get the two case halves to come down flat on top of each other, then we've got a problem. Now, on reassembly of these differential pinion gears, or spider gears as they're sometimes called, there's a clearance check. There's these little V-shaped notches right here and right here. There's a clearance check where there should be zero clearance with this V-shaped notch on this pin where it fits down into the differential case. And so I'm going to put this set in there, and this set here. Actually, it needs to go like this. So we've got the V-shaped shaft pointing down to the V. It's not going down all the way into that V at the moment. Why? Well, because we've got that beveled or Belleville plate that's there pushing up. And so we're going to have some resistance as we put this other case half on. And as we put this on, we've got to be careful that we're not dropping the side gear down and allowing those plates to become unsplined with each other. So I'm going to try putting the differential pinion gears in as with those clutch plates as one assembly. Okay, so on the top and the bottom here now, you can see we've got a gap. So there's a gap on the bottom. There's a gap on the top where that V shape is. And that gap should be totally gone by the time we tighten these bolts down to put the case half back together. But the problem, the potential problem that we have here is that if we don't have all those clutch plate splines lined up, as we tighten those bolts down, we could bind things up. And so I'm going to be careful as I tighten those down to make sure that we're not just bottoming out on a set of clutch plate teeth on those splines. So we pause it for a moment and we'll get those bolts in and start to tighten them down and see what happens. Okay, there's one thing I forgot, a very important thing I forgot that we need to do here on reassembly of this case half, and that is I want to put some Loctite thread locker on those bolts that I took out, just to make sure that they don't come undone, and to clean the threads and dry them before we torque the bolts, because most of the time the bolt torque given in the service information is for dry threads, and I've just put all kinds of lube down in the threads, and the bolts are still covered with oil, which means if I put those in and torque them to spec, they'll actually be torqued too tight, which could cause some problems. So I'm going to lift the upper case half back off. excuse me. And I'm going to use some brake parts cleaner and clean those threads out. And then I have some surface prep for, it's an activator for anaerobic sealants, but it works great for thread lockers. And I'm going to clean the bolt threads up and clean the thread holes out with this surface prep, and then put a little bit of the Loctite thread locker on to make sure that the bolts are dry, and it's the low strength thread locker, the medium strength, the blue stuff, to make sure that those bolts just don't come out when we put this thing back together and drive it down the road. Okay, I've used a brake spray cleaner to clean out the threaded holes that the case half bolts go into. I've cleaned off the threads really well of the bolts, and I've used Permatex, it's item number 24163, surface prep activator for anaerobics, which allows the surface to be good and clean, and it actually speeds up the activation of thread lockers and anaerobic sealants. And one word of caution though, that is that you do not want this surface prep liquid coming in contact with your bottle of thread locker. You don't want that liquid to touch this liquid, because it can get into this bottle and it'll set the entire bottle up hard. And so when you put the sealant, the thread locker, on the bolt, don't let the bottle touch anywhere where the surface prep activator was, or you could end up contaminating your bottle of thread locker. So I'm just using this medium strength thread locker. It tells us apply and assemble. You do not have to wait any specific amount of time. So we'll set those off to the side here for a moment. And then we'll get our differential case reassembled, since I had to take it apart to clean those threads out. So we'll put the differential pinions back in, get the case halves lined up, and back on top of each other. We've got our little gap, like I talked about before, that we need to make sure is taken up when we tighten these bolts. But now it's time to put those bolts in, and keeping in mind that they are left-handed threads, so we're going to turn them counterclockwise to tighten them up. So we'll get these bolts all started and start to tighten them down and see what happens to our little gap there in the V-shaped section. Okay, I've got the case halves together, and I've put the bolts in. I have not tightened them down, torqued them, but I did discover one important mistake that I made on disassembly, and that is we should have made a mark aligning the upper case half with the lower case half. And luckily there's a punch mark already made by someone. I don't know if it's out of the factory or somebody who has worked on this later on, but there's these two little punch marks that you might be able to see. Yeah, right there, and let's see, right there and right there, that you need to align. Now this can only go on two ways, the upper case half versus the lower case half. And as it turns out, I put it on the incorrect way, 180 degrees out of phase. And what I found is the bolts, some of the bolts would go in, but others, they wouldn't line up with their holes. So it must be put on in the correct manner, of course, in the correct phasing in order to get those bolts all lined up and into their holes. So now I've looked up the torque specification for these bolts. The torque specification is 35 to 45 inch-pounds of, I'm sorry, foot-pounds, not inch-pounds, foot-pounds of torque. And so I'm going to get these torqued next. And of course, keep in mind these are left-handed threads, so we're going to be turning these clockwise to get them, whoops, turning them counterclockwise to get them tightened up. And we're just going to go in a star pattern. On the 35 to 45 foot-pounds of torque, I picked 40 as the midpoint. I guess technically it doesn't matter because if you're in spec, you're in spec. But remember, as we tighten these down, we want to make sure that we're not, or that we have the gap or the lack of gap in that little V groove, indicating that we're not smashing any of the clutch discs on those side gear splines. And so in looking at it right now, there's no way that we're smashing a clutch disc because the gap is too small. But there still is a gap check that we're supposed to do with a feeler gauge. Once we get these all torqued where they should be. Okay, so they're all torqued. And now, looking at the gap here, this little V-shaped groove there, we don't want any gap at all, and it looks like there's no gap there. This side over here looks like there's just the tiniest little bit of gap. This side looks like no gap, and the tiniest little bit of gap. So just a little teeny gap on two of those, no gap on the other. And what it tells us in the service manual on this gap is that, let's see, it says check for metal-to-metal contact between the surfaces of the pinion mate shaft V and the cam ramps in the case to make sure there is no clearance. If clearance exists, check for worn parts. So obviously a differential case like this that's 51, 52 years old is going to have a little bit of wear. The wear would be in the shafts themselves that those two little differential pinion or spider gears set on. It can wear that shaft down smaller. The inside diameter of those little differential pinion gears can of its bore hole can get worn larger also over the years. But since we don't have any replacement parts and the gap does not appear to be that great, we're just going to leave it. So the next step is to put the ring gear back on the differential case. Now, in order to install a ring gear on modern vehicles, you're supposed to heat it up. I'm not sure if we'll need to heat this ring gear to expand it out enough to get it on the differential case or not, but we'll find out here in a minute. Okay, I've got the new ring gear right here, and the new ring gear, let's just do a quick comparison with the old one. There's the old one, here's the new one. Height-wise, they look, the 456 one is shorter, the 336 is taller. Here is the 336 pinion gear versus the 456 pinion gear. You can see that it has a much larger diameter pinion gear than the 456. This would take more turns to rotate the ring gear than this one will, because this one takes 3.36 turns, this one takes 4.56. So the physical size of the pinion gear versus the number of teeth on the ring gear make up the gear ratio, and of course the number of teeth here on the ring gear also, or the pinion gear. So it's the number of teeth on the ring gear divided by the number of teeth on the pinion gear give you your gear ratio. Well, we're done with the 456 gears, except for the pinion. We need to get the pinion bearing off and see what pinion depth shim is back there. But what I wanted to show you is, I mentioned a few minutes ago that sometimes you have to heat up a ring gear to get it back on the differential case. And the way that I tell if I need to heat up this ring gear or not is I try to set it down on the differential case. And if it does not set down all the way flush, let me zoom in here. See how we have a gap here? That gap is not going to go away easily. Some technicians will try to put the bolts in from the back side and pull the gear down. That you're taking a big chance of ruining the threads in the ring gear itself and the bolt itself. And so what we're supposed to do instead is to heat the ring gear to 200 degrees. Now you can do that a couple of different ways. You can use just a pot of boiling water. It boils at 212 degrees at sea level, and that would of course heat the ring gear to 200 degrees, and then quickly take the ring gear while it's at 200 degrees and it'll be expanded out. It'll be a little bit larger diameter, and it'll drop right down metal to metal, and hurry up and get your bolts lined up and tightened. You do not want to torque them at that point because the ring gear has heated up and it has expanded. And so if you torque those bolts and then the ring gear cools down, the bolt torque will decrease. And so we're going to have to let it cool down once we heat this ring gear up to get it back on the differential case. Another way to heat the ring gear up is just to go to like an appliance store and buy a toaster oven, an electric toaster oven. I've used a toaster oven for years here, and you just stick this in like it's something that you want to cook in the toaster oven, and crank it up to where the ring gear will get to 200 to 250 degrees, and then using some insulated gloves, of course, like welder's leather gloves, bring it over and line it up. But what we have here now is to heat up our ring gears, and does a really good job, is what's called a hot plate. So I'm going to get that hot plate out next and show you. Okay, this is the hot plate I was telling you about. It's made by Thermo Scientific, and it has a dial here in the front, and it's in Celsius rather than Fahrenheit. But we need to heat this ring gear up to 200 degrees, which is 93 Celsius. But the hot plate needs to be hotter than the ring gear in order to heat it rapidly. And so I typically turn this up to 200 degrees Celsius, which is about 400 degrees Fahrenheit. And then we'll take the ring gear and just carefully set it on top here. This is a ceramic glass top. The reason I have this hot plate is because some manual transmissions have gears that you physically have to heat up in order to put them back on input shafts, output shafts, counter shafts, and so on. And you can set those gears on this plate and take them off whenever you need. Now, how do I know when this ring gear reaches 200 degrees Fahrenheit? Well, there's the best way that I've found to use is with these little devices here called temple sticks. T-E-M-P-I-L-S-T-I-C-K. And you can buy these temple sticks in different temperatures. This one is rated for 200 degrees Fahrenheit, 93 degrees Celsius. And what it is, it's like a crayon, except this crayon is going to melt at whatever temperature you buy the stick for. And they make these sticks that will melt at a whole bunch of different temperatures. I've got a whole bunch of different melting point of these temple sticks. But we're looking for 200 degrees here. And I'm just going to draw a little mark on this ring gear. Let me zoom in so you can see it. Right here. Right now it goes on dry and is not melting. But as soon as this ring gear reaches 200 degrees, that will melt. And so that's an easy way to tell when we reach 200 degrees. So we're going to have to wait for this ring gear to hit 200 degrees before we can proceed with the installation of the ring gear. Okay, we've let the ring gear sit here a while and heat up. I don't know if you can see it, but the crayon has melted, the temple stick. We put a little bit more on right here. It instantly melts when I put it on, so that tells us that we are at or above 200 degrees Fahrenheit. So the next step, of course, is to take the ring gear, which is really hot, so I'm going to be wearing these welder's insulated gloves here, and pick up that ring gear and put it on the differential case. So turn off the heat, the ring gear, and of course it sets right down quickly. The problem is we've got to line up a bolt hole right there before it cools off. So I've got one bolt started, another bolt started. There we go. And as you can see, it's right down metal to metal, just like we want it to be. Metal to metal, no gap at all there, and that's how it should be when we put the bolts in. We've got to make sure that always make sure that's down metal to metal. Get a couple of bolts in to make sure that it's aligned properly, so when it cools off, it's going to contract and get real tight on that differential case. Once it does that, if you didn't line those bolt holes up, it's too late. You'll have you'll have to knock the ring gear off with a brass drift, and then heat the ring gear up again and reinstall it. So let me get this hot plate out of the way and let it cool down. It only took about 10 minutes to heat that ring gear up using that hot plate. That's pretty impressive. So anyway, we are going to let this cool off now before we tighten any of those bolts. And then once it cools off, and it'll cool off enough that you can tighten the bolts in about an hour. Typically, we will do this before going to lunch in one of my classes. And by the time we get back from lunch, everything is just warm to the touch rather than hot. And we can torque the bolts at that point. Or, even better, is do it at the end of the day, end of your class, end of the day, end of the work day, whatever it may be. Set it on here and let it cool down overnight. That would be even better. That way, for sure, everything is the same temperature. So I'm just making sure that I can start every single bolt before I let this thing cool down. As you may be able to see here, yeah, you can. There are gold lock washers with these bolts. So these are brand new bolts and they have lock washers. This ring gear was intended to have lock washers with it, and that means that we do not need to put thread locking compound on these threads since it already has a locking washer. So we're going to let this cool down. Okay, to finish the reassembly of the Positraction differential case unit or assembly here, we need to install the side bearings, and we're going to press them on with the arbor press. There is a special General Motors tool that we do not have that fits these bearings and will drive them down below the top of this surface right here. So I can use a regular disc, a replacer disc, to press this down flush, but then I still need something to take it down farther. So what you can do, if you don't have a tool or a pipe that'll work, is you can take the old bearing. So I've taken the old bearing inner race, I've pressed out the race from the cage so there's no rollers here. So this is our old bearing, and I'm just going to simply turn that upside down and use that in the press to press this bearing down, recessed like it should be on each side of this differential case. Once that's done, then we can put that in the differential housing once our pinion gear is installed. But I did run into one problem after the ring gear cooled down. Remember, we heated that up to at least 200 degrees. And I let it cool down, and then I used my brand new torque wrench, Snap-on torque wrench, to torque the ring gear bolts to 55 foot-pounds, which is the instructions that came with the ring and pinion gear set. When comparing that to the specification in the service manual, the service manual says 40 to 60 foot-pounds, so it's quite a wide range. So I just went with the 55 foot-pounds that the ring and pinion supplier gave us, and I ran into a problem, and that is the bolts started to stretch at about 53 foot-pounds. These two bolts did. The rest of them torqued okay. But these are some grade 8 bolts, and that's a pretty hard bolt, but the maximum torque allowed on this type of a bolt, I looked it up in the Society of Automotive Engineer specifications, is 49 foot-pounds. So it's no wonder that these bolts stretched. These bolts are physically longer. One of them's longer than the other one. I think it's this one over here. It's about 1.12 inches, and this is 1.08, something like that. So the way you can tell if a bolt is stretching is while watching the torque wrench, the digital torque wrench. The numbers are going up as you're tightening the bolt, and then it doesn't keep going up. It starts going back down, and at that point, you better stop, because if you don't, this bolt will continue stretching and will break off inside of the threads there, inside the ring gear. You'd have to totally remove all of these bolts again to get that broken part out. So we're going to have to find some replacement bolts. As a matter of fact, I think I'd like to replace all of them. Let's see, we've got 2, 4, 6, 8, 10 ring gear bolts here. I think we should replace all of them and only torque them to about 49 foot-pounds rather than the 55. Now for now, the rest of these did torque properly. I'm just going to leave these two out for the rest of the assembly of the differential housing. But as far as assembling the differential case, besides these two bolts that I need to replace, the only parts left to put this case back together are the two side bearings. So let's put those on next. Okay, here we are at the arbor press. I'm going to take this differential case, set it carefully there, and got a little bit of gear oil here. I'm going to lubricate the surface where this bearing is going to be pressed down, and also lubricate the inside of this bearing. Set that right there, and we'll take our makeshift tool, the old bearing inner race, set that upside down there, and then we'll take one of our bearing driver discs. It's too big for this bearing, but it doesn't matter because we're going to put it on top of the other old bearing race. So we'll just bring that ram right down center there, and let's zoom in. I'm just going to pull down and press that bearing. Okay, we've got it down flush, but we don't have it recessed yet. So you can see that it's flush right there. Now we've got to get this the old bearing race centered just perfectly, or it's not going to be able to push it down and recessed. Let's see if that does it. There we go. Yeah. So down it went. Got the old bearing race there. Now that's probably pressed itself on to that little recessed portion there, but that's not a big deal. I'm just going to get the brass hammer and tap that back off of there. There we go. Comes right off. Okay. Now we got to put where you can see the recessed area there. We've got to turn this over carefully without damaging that bearing, and press the other bearing on. And it also needs to be recessed. So we'll put some lubricant on there and on the inside of the bearing itself. Sit there. Sorry for bumping that there. All right, and then the old bearing, and I'll replace
slicer disc. Lined up the best we can. And here we go, pulling it down. Down all the way to the recess also. Yes, it did. That took it all the way down, so we'll lift that back up. Just comes right off, and you can see that we've got the recessed area right there, and the bearing is down as far as it is supposed to be. And the arbor press is a great way to do that. No hammers involved, no hydraulic press involved, no accidental wedging or binding of the bearing. And that's a great way to install those. So this completes the reassembly or the disassembly, inspection, overhaul, and reassembly of the Positraction differential case. On the next day, we are going to totally reassemble the rest of the differential housing and get everything set up so it can go back in the vehicle.